Let's look at this the other way. Suppose we know that we want to find what some angle such that the sine of that angle ends up being a particular measure. So if we have an example where we have a triangle where the ratio of two sides, x and y, I guess that would be z down here, the ratio of these two sides, I'll just do x and y, and we know that x divided by y is 0.728. I'm trying to figure out what angle this would have to be to make that true, or what angle this ends up being. I'm trying to measure it out on my protractor or something like that. In other words, I want sine of A to be 0.728. Well, to figure out how to do this, I need to basically tell the calculator, well, kind of go the other direction. Don't take the sine of 0.28 because I want to take the sine of my angle to get 0.728. So what I want to do is I want to take the inverse sine. Sometimes this is called a sine. Sometimes it's called sine with a -1 there in the exponent. But both of these are referring to the inverse sine. On my calculator, let me see how it shows up on my calculator. It's actually, you can see it doesn't show up on here at all. Actually, I wonder if this would work. If I did something like this, sine, I doubt it. I don't think this is going to work. Yeah, okay, so that doesn't work. So instead, on this calculator, I need to go into the additional functions, and you can see it's actually a sine. That's how I'm going to do the inverse sines on this calculator. On a graphing calculator, like this one, you can see, well, it's kind of hard to see here, but it's in yellow. Right here, it says sine with a -1 there. So I would do inverse sines using that on this calculator. I'd go inverse sine of, what was I doing, 0.728? 0.728. Inverse sine of 0.728 is 0.81. Actually, I should make sure this is in the correct mode. Alright, so one thing when you start doing sines and cosines on your calculator, if your numbers aren't coming out the same as what mine were, you want to check to make sure your calculator's in the correct mode. And the mode here is deciding whether your calculator is going to be giving you the number in radians or in degrees. By default, this calculator gave me the measurement in radians, not in degrees. So if I switch that over to degrees instead and quit back out of here, now when I evaluate the inverse sine of 0.28, I get 46.7. And if you actually, if you kind of look at this, 46.718 times what, pi times pi divided by 180. That's the usual unit conversion, the way we convert degrees to radians. You can see we get that 0.815 whatever. It's not very accurate though, because I only went a few decimal places. In any case, you can see this gave me the same angle, but it gave me the measurement as radians. I actually wanted it as degrees, or I might have wanted it as degrees. I guess it doesn't specify here. Yeah, okay, so I guess in this example it says give it to the nearest tenth of a degree. So you want to make sure your calculator is set in the correct mode. Let's look at this calculator. I think I can probably change it to, yeah, so in this calculator, if I say angle, I can either have it give me stuff in degrees, 0.728. You can see this gives me 46.7. That's the same number as what this calculator just said, 46.7 whatever. Or I can change it to radians, in which case when I do the inverse sine of 0.728, it gives me, okay, maybe maybe this calculator doesn't do things in degrees at all. You have to actually go through the unit conversion. Whatever. In any case, most of the time your calculator, it'll either say up toward the top of your display. You might have seen this on your calculator. Often it'll say rad, and if you press a certain button, it'll change it to deg, and if you press it again, it might change it to grad. These are three different angle measurement modes. Of course, this one's radians, this one's degrees, this one's gradients. We're not going to be using gradients at all in this class, but that is yet another form of measuring angles and whatnot. So, yeah, there's all sorts of different ways to do this, and depending on how you do it, well, yeah, you should be able to, as long as you're consistent with your methods, you should be able to make everything work out. But you just want to be careful there. All right, in any case, if you want to find an angle such that cosine A is 0.589, this says round each of these to the nearest tenth of a degree. I guess before I move on, there's also inverse cosine, that's a cos, or cosine to the -1. There's also inverse tangent, a tangent, or tangent to the -1. Since we're trying to, on this example, we're trying to figure out the inverse, I want to use the inverse cosine. So a would be the a cosine, a cos, of 0.589. So I will go ahead and do that on this calculator. I'll say, let me clear off that. I'm going to do a cos of 0.589, which gives me 53.9. I'm rounding this to the nearest tenth of a degree, so A is approximately 53.9 degrees. For the inverse sine of 0.248, rather, or an inverse sine there, I'll get rid of all this other stuff. 248, and we get 14 point, rounding this to the nearest tenth of a degree, that's going to be 14.4. A is equal to the inverse sine, a sine, of 0.248, which is approximately 14.4 degrees. And inverse tangent, I'm going to go a tan. I had to scroll down there for a little bit to get to it. The inverse tangent of 1.75 gives me 60.3.